So I'll be giving introduction about
Okay.
university support.
Very good evening to all of you, and welcome to this 18th distinguished lecture being organized by INA Bhubaneswar chapter, SOA University, and IMT Bhubaneswar. And it is heartening to know that this month itself, including this one, we had 3 such lectures. One was actually the last month's quota, which we couldn't fulfill because of technical reason. But this month, actually, we have shifted it to it, and we are going ahead today. And this is the 18th lecture. We started about a year back, not a year back, exactly last December, and we used to have one lecture every month, and in between we changed it to 2 lectures per month, and I'm happy that it is going on very well, and we are getting participants from all over the country, including some people from UK and Israel for our lectures. So, and we have got very good feedback on this lecture, and we will continue to do so. So, today we have with us Professor Ashok Kumar Pradhan, who was my colleague in IIT Kharagpur. Professor Ashok Kumar Pradhan, who is a senior member of IEEE, received his PhD degree in electrical engineering from Sambalpur University in 2001. He has been with the Department of Electrical Engineering, IIT Kharagpur, since 2002, where he is currently the Institute Chair Professor, and also he is the Chairperson of Subir Chaudhary School of Quality and Reliability. His research interest includes power system, relaying, and wide area measurement-based monitoring. Professor Pradhan is a fellow of Indian National Academy of Engineering. He is also a fellow of National Academy of Sciences and a Young Engineer Award recipient from INA in 2001. He has published more than 100 research papers in high-impact journals. He has served as visiting positions in Technical University Darmstadt, Germany, and McGill University, Canada. Professor Pradhan has been involved with several projects in smart grid and microgrid areas. He was in the advisory committee to small hydro projects, Government of West Bengal, during 2017 to 2019. He has been instrumental in imparting knowledge in the area of numerical protection to more than 1,000 practicing engineers of Tata Power, Calcutta Electricity Supply Company, Damodar Valley Corporation, NHPC, etc. in the last 2 decades. As an industrial consultant, he has been involved in solving several issues of Damodar Valley Corporation, CSC Calcutta, and Odisha distribution system. He has a popular NPTEL course on power system protection and benefiting students and engineers. So it is very heartening that Professor Ashok Pradhan has agreed to give this very important lecture on improvement of precision time in electric grid availability and usages. So with this brief introduction to Professor Ashok Pradhan, I will request him to please make his presentation. Today we are not able to give anything about our university. Most of you actually, you have learned about it, but still in a brief, I will request Professor Renu Sharma to say a couple of words and then pass on this thing to Professor Pradhan. Professor Sharma, please.
Thank you, sir. Thank you, sir. From the humble beginning of over 25 years, Shiksha Anusandhan deemed to be a university, known by its acronym SOA, and has emerged as a shining academic edifice today, which has illuminated the educational skyline of Eastern India. A society inclusive institution of higher education focused on the quality education and innovation research. SOA has been the churning out professionals in varied fields ready to meet the requirements and challenges of different sectors. Coming into existence on July 17, 2007, when the government conferred on it a status of deemed to be university under Section 3 of UGC Act 1956, SOA is considered as a center of superlative professional education today. The university is a home of nearly 15,000 students, including from 15 foreign countries who have chosen SOA to chart out the future for themselves. The university has faculty-student ratio of 1:10, with a number of faculty with a PhD or equivalent degrees accounting for more than 75% of the teachers. Though just over 15 years old, though it is just 15 years old, SOA has been continuously listed among top 25 universities in the country by NIRF, instituted by Ministry of Education in 2016. For 7 consecutive years, SOA has been ranked 16 in the country by NIRF in just release ranking of 2022, making the 3rd best university in Eastern region. SOA's mission is to become the leading education in higher learning and its chosen areas to prepare future generations through quality teaching and innovative research. Its mission is to become responsible, enlightened, and productive citizens. In NIF ranking 2022, SOA's Faculty of Engineering and Technology, ITVR, ranked 27, Faculty of Medicines, IMS SUM, ranked 18, Law ranked 9, Dental ranked 10th, and overall category SO ranked 30. Already a name of reckon with the realm of higher learning, SO reached a huge milestone recently with NAC, accredited SOA with the highest rate of A++, with a cumulative grade point average of 3.88 out of 4. The recent decisions on UGC to grade SOA accredited category 1 deemed to be university has become as the newest feather in the university already glowing cap. SOA has globally ranked around in the bracket of 801 to 1,000 by prestigious QS World Ranking. And many more are there. And looking at like QS iGauge for outstanding performance in 2022. So as also only the institute in the Eastern India to get QS iGauge Elite for conducting online teaching learning during COVID-19. And world ranking, the Times Higher Education 2001 plus category in the university ranking, while it got the rank of 601 to 800 bracket in engineering and technology and computer science in 2022. It is also ranked as 601 plus category health sciences, 401 to 500 plus bracket in THE, the Asia University ranking in the same year. Many more are there in list, not including much here. We would invite our guest, the speaker of the today, to deliver his lectures.
Professor Pradhan, please start and share your slides.
Okay, sir. Actually, no, nothing problem, sir. I like to open it instead keynote. Yes. Is it visible, sir?
No, no, not yet. Please come out and again.
Not visible, sir? Okay.
No, no, not visible.
Yes, sir.
Yes, now it is visible.
Okay, sir.
Please use it at the full screen so that it will be.
Is it not in full screen, sir? Okay, let me see.
It is visible.
But is it not full screen?
No, it is okay. We are able to see, but it is not yet full screen. Okay, we are able to see.
I think we will manage. Yes, sir.
We'll manage. No issue.
Okay, sir. I don't know. It is as best as possible from my side. So, good evening, namaste. Really, this is a great privilege for me, and that to say in front of my earlier director, Professor Acharya, and great initiative from his side to enrich the researchers and communities so that young minds can be enriched through this process. And with the INA Bhubaneswar chapter, so this is a new look into that. And my thanks and congratulations to SOA also in a small period of time. So far the university has grown like so, and my best wishes to that part also. So with this, we'll begin this this evening's presentation. So Professor Acharya asked me to have this INE chapter presentation, and because it is a online virtual world, so very difficult to know the audience who will be there and so. So then I thought and decided that this will be a public lecture kind of thing, generic in nature. So I thought because my domain is power system or electric system, so I thought a title like this: Importance of Precision Time in Electric Grid, on its availability and usages. So this presentation talks about how with the evolution of this electric grid with time, this the time itself becomes so precious to the electric grid operation and management. That is the focus of this presentation. So through this, we'll talk about how this the corresponding timing can be obtained, so-called the precision time, and then its the numerous application perspective and so. So in my presentation, my submission is that I will be not using any equation, and it will be not in details of technical side. So I believe you can see that it will be understood to those who are aware of this electric grid perspective to most of the cases. First, we'll emphasize why time is so important today in the electric grid. Few slides are there for that. And then what are the platforms where the corresponding so-called precision time is being achieved? And then how the precision time is valuable and in the different application perspective in the electric grid. And we'll also talk about those who are working may be interested on cyber security issue related to precision time, how that also is coming into picture and then influencing this domain also. And then we'll have some remarks, concluding things and so. So the point is that the concluding remarks will tell us that what is the challenge left out so that the future grid like to harness better time precision and then better applications and better management and better reliability of the system. So that gives us a scope of future works to be done, future research in that direction. So with this we'll proceed. So we know if we go to this perspective, so this is about electric system. We talk about that. So this electric system encompasses sources, transmission system, high voltage system, low voltage system, distribution system, loads, renewable energy, so many perspectives and so. Yes, India is also beautifully managing this grid, very competent grid in the global level also. But then with the more and more renewable resources, this is more challenging today because the renewable resources behave in a different way. So they are, we know, we can say that the renewable resource importantly like the solar for us and the other one, the wind, they are intermittent in nature. So that creates more challenging to the electric grid perspective and so. So the electric grid operation becomes more challenging in demand, meeting, and so we have already reached, we have crossed, you can see that more than 210 gigawatt and so, and every day it is increasing rapidly with 61 gigawatt of solar, wind of more than 40 gigawatt. India already harnessed to a capacity of more than 400 gigawatt of that. And out of that, if you combine these two, the renewable resources that goes to more than 150 gigawatt, around 160 gigawatt kind of thing. So that is a achievement for us. But then the challenge is on the management perspective and so on. So when we talk about the Indian grid, we talk about the grid itself is India grid is itself is synchronous grid. Not like US or so, they are not having multiple, you can say that asynchronous things and then connected. However, they are electrically connected. So when you talk about a synchronous grid, is one grid, one frequency, and that happened following this 2012 blackout in India, 2 disturbances in July. So that paved the way for the improvement on that perspective, and we are managing very well henceforth. So this, when you understand those who are in electrical science and electrical sciences, so you know this synchronization of alternator, generators, and so synchronize of the system. So there is synchronization of the grid. So there is one perspective, but the the point which we'll address today is about the time synchronization perspective, something more on that. But there is a correlation between these two also. One is that the phase and the corresponding time are also related into that. So this is about in general that the electrical grid managing well and so, and then we have a lot of renewables and new, you can say, dimensions into that. But then what we say, the system does not, you can say that go like that always. This is a September 2nd, this month only, in an event in Netherlands, you can say that. And what happened that the event that the corresponding protection system failed, and it failed for 50 seconds, not milliseconds or second, 50 seconds or more. And then the corresponding greater than 100 kV system line having the fault current significantly, you will see that this is the line start melting and going down and tossed to a railway, you can say that supply system. And then therefore you can say that short circuit happens to be there and the fire continuing. See this video, if you see, just you can say that after that, it will show also that how the conductor goes down, and you'll see fire on this conductor also on the high voltage transmission system also. So these you can say that is peculiar, you can say that observations, however, there is no loss of life and so. So this point, the point of concern is that we have things very running very well, fantastic, but at times it is very detrimental and affecting the large community and so. The point here is that there is a delay between transmission. So the point here is that we have blackouts also. History of blackouts, you can say that. And India is topmost in terms of this ranking of the population affected by the July 2012, you can say that, events. 62 million people, you can say, as per the UK record, were affected on that day. So this is about the list of, you can say that, great blackout events and so. And if you see this UK, you can say that database on 2021 also, this is about the number of big, you can say that, blackout events and so. So blackouts happens very regularly in different grids. You can see the history, you can say that, and in the Google or Wikipedia and so. So, however, we say that when power fails, then we think about that and so. So, like that, what happened that we talk about this year, the 2003 blackout in US and so paved, we can say a lot of things and so. Okay. On coming to this blackout or large scale disturbance and all these things, how the corresponding time as information electric grid maintenance becomes significant, that will come to that point. Sir, I have a question to you, that how much time you allow me? Sir, can you please tell? I'm sorry to ask you.
Sir, till 6:15 we are moving on. Sir, till 6:15 will be continuing, and another 15 minutes for question answer sessions.
Okay, fine. And the question what will be? You will be asking from the reading these questions or anything or directly?
No, sir. They will unmute the mic and they will ask.
Okay, fine. Thank you. So this is about this how the corresponding time information becomes important. That will come to this perspective and so. Power grid is a single, complex, and interconnected system. Perhaps one of the more, I'm sure that one of the biggest, we can say that man-made, we can say that system in terms of that. What happens in one part, the grid affects the operation elsewhere. So it is not like a road here, something at Kharagpur, something happens on the road, some accident or so may not be affecting at Delhi and so. But this electrically connected whole grid is connected, as I mentioned about the synchronously connected grid. Therefore, an event here may be considered triggering and affecting the in and around the large scale event and finally reaching to the whole Indian scenery also. So that is what that electric system is different in terms of that. The other point I like to say that because electric grid, when you talk about any other systems, you can be talking about in terms of hours, day, hours, minutes, second, and so. But here we are talking about in terms of a millisecond also. So that's the, you can say that big difference between electric system management and operation perspective and so. So the point here is that understanding and controlling these interactions, the grid interactions or disturbances in the system. So this requires means to compare what is happening at one place and at time with that happening at other places and at the same time. So what is happening at one place at one time and what is happening at other places at the same time. So that's where it is spatial and also the time is coming to picture in terms of that. So if you go to the, you can say that a lot of major events, you can say that, and the corresponding their recordings and you can say that databases and all these things. So the report and data files are enormous. So when the event happens, large scale event happens to be there, and interpreting these files in a system wide basis requires establishment of a common frame of reference. Now, what is that common frame of reference? One is spatial frame of reference, and then where, and the other one you can say that what happened where, and then as well the temporal frame of reference, what happened when. So these two are you can say that essential part of when we are going for the analysis of any records or event, you can say that post-mortem analysis also. The spatial time of reference comes directly from the network topology, which the engineers know. There is a system about the electric system the engineers know, which is generally known to the engineers, and the accurate time mark in the data files, however, establishing temporal frame of reference is not possible. Is not possible unless it is being the time is being embedded there or stamped there or so, or recorded there or put, you can say that written there and so. One point here is that I'll say here that okay, this map is not visible that way. Fine. So see electric grid people may be confusing about that this time or so. We know about that the critical clearing time, fault clearing time, and so. Yes, so that leads to the stability of the system. So this diagram shows about that if the corresponding protection system does not operate to clear a fault, then the system may be unstable, and particularly the particular generator also may withdraw, and that may trigger one event after the other event happening to the cascading failures and so. So when you talk about this critical clearing time, we talk about the sooner the corresponding fault should be clear, the better it is that. When you go to this 400 kV, 765, 800 kV system and so, we are left out with few milliseconds to clear those faults. Otherwise, system may go to instability and so. Now, the point of the corresponding temporal information or time information when you talk about is about the systems, two stations, station 1 or 1 and 2, the location 1 and 2. We see that the corresponding waveform here and waveform here, when you like to compare these two, or what happens when in the left as compared at the same time instant at the two, then at the right hand you can say that bus also station. Then what we like to say that the same time means the clock of the first and the clock of the second station must be the same. So what happens that like our clock, my clock and your clock may be drift with time. So that is what the tricky point here. The measurement point, the measurement systems here, station 1 and station 2, the clocks there you can say that may drift with time. If that drift in time is acceptable or not acceptable, that becomes a question to us. And in most of the cases, when you are talking about the high voltage bridge management, all these things, it is simple clock that does not, it's not adequate. That we like to see in terms of that. Now, we have a history of, we can say that, see, we talk about in terms of that, Plato said that our need will be the real creator. It's true, very, very true. You can say that the other way, you say that necessity is the mother of invention and so. So what was the necessity, you can say that created this interest on the precision time, and then you can say that the evolution of the precision time platform and so, that we like to see also. So what happened in 1982, there was a cascade tripping and big blackout kind of issues, you can say that in the US, in Colorado area and so. And then when the utility people sit together to analyze the event, postmortem analysis, then they come out, you can say that with a lot of printouts, charts and so, strip charts, that is dot points and so, plottings and so, and try to analyze. And the essential question was, how does my recording relate to yours? So you have to relate, you can say that one utility to others, or one station measurements to another station. So that requires that this did this transmission line trip fast start and break up, or did it, another utilities line trip fast? So this the big question, you can say that we are read, and it was being unanswered in terms of that, because the bottom line take is that we know the network and system special, but we don't know about the temporal, the time information was missing. So that you can say that is the experience in those era, you can say that 80s and so, and that such activity is called for time synchronization. So that I pointed out that yes, we have to record, you can say that the events in terms of with time information, but the time information of one station with time information of other station must be compared. But we know that if you put individual clocks, they with, you can say that time, they also drift, you can say that on their own way. So this is in that era, you can say that the need of, you can say that time on the grid perspective was important for diagnostic and so. So these kind of analysis of events have been synchronized to same time frame of reference that was the need. Therefore, time sequence of data becomes a critical factor in analysis of power system events. So that's why that was the ask, you can say that in terms of that. Now, the next is why is synchronized time important? So important, we are further into that. So in 2003 blackout, August blackout, which was, you can say that most of the analysis records and so, and also that initiated Obama's initiative of billions of dollars for investment, you can say that, and the smart grid technology perhaps evolved from that onwards. So this analysis took, the analysis of this 2002 blackout took 2 months to establish the exact sequence of events to understand the root cause of analysis and cascading. And the due reason from that was nothing but the time synchronization was missing. And that's the, you can say that North American Electric Reliability Corporations recommended that all the recordings must be considered time synchronized. That was, you can say that the starts. So in 2011, then event occurs, and that was having also occurring in US, and that having 100 notable events, you can say that during a span of 11 minutes or so happens to be there. And then you can say that with recordings available with time information, then it took only 2 days to establish this one also. See? So this, but the delay were on the 2 days also, where the question was that the varied time stamping methodology, format, sources, and synchronization. It means that the time information at different places are also is having varied formats. The time stamp, you can say stamping information, methodology were also different, formats different, and the source of synchronization are also different, and that put also bottleneck in this the need of, you can say that, precise time information and so on. So the need of timing in substation began with the introduction of digital relay. So with the, we know those who are in the numerical relay protection and so the digital relay also progressively went on, you can say that, to be more and more, you can say that, incorporated into the grid, and that digital grid becomes a storage element, and that's, you can say that, gave a platform to also have different recordings of the event and so. So the other reason what happens that in order to execute remedial actions, that was I was talking about the post-mortem analysis, but now we talk about the remedial actions. You can say that how to manage the system in real time. So there was a need also. So it was impossible to see that what is happening in other places as compared to this place at Kharagpur. What is happening at Delhi and Mumbai and Bhubaneswar is not known. So therefore, that will happen. You can say that in terms of what that will, if we have a platform where the real-time situational awareness can be happen to be there. So in terms of that, we essentially need information. What is the source generation at different points? What is the health of the different lines, and which line is operational, which line not operational, which line is highly loaded, and so. So this set of information is required for the operators to make certain decisions in real-time perspective, and so maybe automated, or maybe you can say that decided by the human being, and so. So this control system operators, you can say that also needs the states to be estimated, and that state estimation of the whole India grid kind of think of that becomes very massive, challenging things. However, with the introduction of the so-called synchronized platform, we'll come to that on the PM or phasor measurement unit or synchrophasor technology, the state estimation becomes realizable in terms of in a linear equation also, and then the corresponding states are also directly, you can say that, obtained from the measurements also. So thus, from these few discussions, we said that there is a need of time synchronization across the rig, and that has a possible application scope for real-time applications or diagnostics and many other application perspective and so on. So now we'll talk about that. What is the platform? What is the source? Or what is the ways we can go for the time synchronization perspective? And this time synchronization is not only important only for electric grid. It is for many, you can say that, systems, including the mobile telecommunication, mobile, or you can say that different, you can say that mobile networks and so and so. So network time synchronizations, when you talk about it is a network time, it means that it is not the electrical network you are talking about. We are talking about the time information at different places, that itself becomes network. Okay, so here you are talking about, let us say, a lot of developments happen to be there in the mobile technology, and so we are talking about here 5G. You can say that technology also. The different synchronization techniques are available to provide network timing, and several methods synchronizing a clock and network, the time, frequency, and phase. 3 things are there, which that information is being provided in the time synchronization perspective. Frequency refers to the number of complete oscillations per second provided by this such a platform, and phase refers to the fraction of cycle for periodic quantity, and so we'll come to that. And time refers to the time of day. In a day, what is the corresponding time at what instant, and so. And the clock synchronization is a major component on the functionality of 5G features. Otherwise, it's very difficult to realize 5G technology and so. So while going to this time synchronization standard IEEE 1588, we'll go. If you look at that, then we find two terminologies called synchronization and synchronization. Interesting. Synchronization talk about tone. Tone we can say corresponds to tone. Tone corresponds to frequency, and synchronization means it is time synchronization. So this is synchronization is of that about the corresponding frequency and the synchronization of the time synchronized perspective. If you see this first, you can say that plot here, there are two clocks here, clock 1 and 2, yellow and blue. So if you see here, the two clocks having different frequency, so it distances and here distances are different. This is about the time. So again, you can say that you see here, the two clocks, they do not have anything in common. Complete mismatch, asynchronous and asynchronous. Neither frequency matching and neither they are synchronous with time also. They are this pulse you can say that does not have in that same, this pulse does not have a pulse at the clock 2 also, corresponding clock at clock 2 also. However, if you see this plot, here what you see that these two you can say that having the same same you can say that frequency. So that means that they are synchronized clock. Okay? They are having the same frequency, but they are not necessarily produced, you can say that congruently. So that is what we need. Now, if you go to the third plot, these two clocks, you can say that having each one having following the other one. So they are having perfectly synchronized. So that is what we talk about. You can say that the synchronized, you can say that clock 1 and clock 2 are synchronized in terms of that. So the both frequency and the corresponding they are synchronous with respect to each other. Now there are different platforms. We'll talk about that also. So let us say come to this the GPS known GPS you can say perspective and so which we use in mobile also. Global positioning system requires precise clocks to provide astounding precision accuracy, and the atomic clock in the GPS that gives us a 3 nanosecond accuracy. 3 nanosecond, not millisecond or microsecond. It is 3 nanosecond accuracy kind of thing. Now the position accuracy depends on the receiver. And the corresponding, we'll talk about what are the different varieties of you can say that platforms. Most handheld GPS, even including our mobile, you can say that when we are walking, you can see that the accuracy level is around 10 to 20 meters. But there are scope of, you can say that in terms of this military and all these things, they are even including a differential GPS. In differential GPS, you put you can say a platform for one antenna, and then you can say around you can say that we go around that. Then you can go up to the 1 centimeter, you can say that precision also. This is about the locational, you can say X, Y, Z coordinate perspective in all these things. And when you talk about the time, it gives a 3 nanosecond accuracy in terms of that also. But the GPS based platform, like we see here, you can say that these are satellite based. So there are so many satellites, you can say that having 24, you can say that satellites are there orbiting in 6 orbits, you can say that each orbit space is 60 degree apart, you can say that, and then inclined, you can say that, and so position is in terms of that. And each orbit, you can say that about this Earth with a period of 12 hours and so. That you can say that leaves us, you can say that the scope that at one location, if you put, you can say that some antenna also that can see at least you can say that 4, you can say that satellite at one instant of time and so. So a satellite broadcast the same frequencies, all the satellites, they provide information at the same frequency. Each satellite broadcasts its position, its own position, GPS time, the time information from the atomic clock, very precision, 3, as I said, you can say that 3 nanosecond and so, and universal coordination time. That is what the universal coordinate time information it provides with that high accuracy, and generally information about the other satellites and so. So each satellite broadcasts data modulated on a different pseudo-random code. So it is a modulated one. So you have to decode it, you can say for this one, and this call you can say that gold code you can say as per the name of the coding perspective. So when you are receiving this corresponding time information from the GPS system, then you have to demodulate it, you can say that, to extend the corresponding time information sent by this satellite, you can say that, to the particular thing. So you have an antenna here, and then this is what you can say that at your device levels and so. Of interest to the power industry on this platform, the standard positioning system SPS signal broadcast, you can say that at 1575 megahertz kind of things. So this is about, we talk about two, one is L1 signal, the other is L2 signal. So this each satellite also broadcasts a precision positioning service, PPS, not only SPS, also PPS also. And signal 1 and 2, that is L1 and L2 considered signals, and it's called commonly considered called the Y code, and it's available only to those users considered for US Departments of Defense. So it is a secure, you can say that things. You have to consider that get the license from the DoD for that perspective and so on. So this you can say that requires licensee and all these things. But then you can say that the corresponding image depends that you can say that combined thing, you can say that gives us an accuracy in the positional things in terms of very high accuracy in terms of this space also. One in the initially you can say that this corresponding platform is available, it is available free also right now for this L1 signal, not to the L2 L2 perspective and so therefore you can get a resolution of around 10 to 20 meter and so. So the point here is that in the after that you can say that the US defense thought that why with that precision and all these things you can say that that may be detrimental to their you can say that nation from defense perspective. So therefore what they did that they introduced intentionally about some selective, they call you can say the selective availability, and then it was having a probability of 95%, and they intentionally introduced some noise and so that at times you can say that that signal will be not available. So that jeopardizes the. However, with Russia introducing similar platform, you can say that in 1996, after that the defense organizations allowed you can say the L1 signal to be available throughout, and this started in 2002. You can say that 2000. Bill Clinton, you can say that removed you can say that selective availability perspective, so it is 100% available throughout the system and so. So for information, each satellite carries several atomic clocks, and then you can say that the block 2 and block 3 satellites have two rubidium and 2 cesium slot on board. So that's you can say that the so high accuracy and high reliability of this perspective and so. A second, that's I talk about that. These all these you can say that are categorized in terms of the global navigation satellite system GNSS, and under that you can say that we have other things also, including the Russia's GLONASS. You can say that constellation and so satellite platform and so. So that's you can say that another platform available in terms of that, and that also the signal is free to us also. So the GPS antenna needs to have a good view of the sky. The antenna should be placed at the good that view of the sky, so that the signal strength becomes sufficient to it. And then you can say that the cable which will be connecting to your measuring devices should have a limited length in terms of that. So that can be considered typically 100 to 120 meter or so. You can say that at back and so. Otherwise, the delivery of signal becomes very weak and so. Now, what are the advantages of the consider the GPS timing over radio broadcasting? Radio, you can say that time and frequency services, which is an alternative way of this. The radio time and frequency service you can say that is a localized one. However, you can say that the GPS platform is a global one in terms of that. And then we talk about the accuracy level. So typically this GPS platform provides at the measurement level also a 10 nanosecond accuracy measurement level. And whereas you can say that the radio you can say that perspective gives in terms of millisecond and so. So that is what the outperformance of you can say GPS platform and so. But to we'll see you can say that afterwards the GPS also has limitations. So far we are talking about the great precision time for the electric grid perspective and so. So IC 61850 standard uses the allows you can say that the CR Ethernet communication perspective, and it uses the precision time protocol, and this protocol you can say that is very promising and in terms of that, and this protocol allows you can say that the corresponding signals to be in a subsystem to be circulated, and then itself you can say that timestamps and so, and that becomes pretty reliable in terms of that. And thereby what happens that we'll come to that also later on about that how the merger unit and all these things that play a role, and that enhances the consider the reliability of the subsystem automation process and all these things. But this the PTP precision time protocol over this network time protocol is that the precision time protocol operates in with a fiber optic cable, then you can transmit the corresponding event time signal also in terms of hundreds of kilometers and all these things, which is not possible otherwise in other platform and so. So we have, you can say that the corresponding GPS receiver, which receives from this corresponding antenna, a corresponding satellite perspective information, and there are three things here: this pulse per second information, and the I'm say that the universal coordinated time, coordination time. And this 10 megahertz, you can say that the corresponding signal, you can say that, comes from this corresponding the receiver. So that you can say useful. The ADC uses the corresponding 10 megahertz signal, and this the the real-time clock uses the corresponding UTC time available from this antenna receiver, and the corresponding PPS receiver go for the time taking, you can say that, for the different events recording and all these things. So three things are being received from the antenna, from the satellite information, then antenna, and to the measurement process. So one example here, you can say that the Switzerland Engineering Limited, if you go to this and others also, that they have now provided a helper oscillation options. Now what happens that by this way, even you can see that the corresponding GPS signal is not available to do to that. Some regions will come to that later on. That this the corresponding crystal oscillators PCX, so you can say that, which happens to be there in the system itself, that allows, you can say that, even if the corresponding GPS signal is not available, a trip time of only, you can say that, 5 microsecond on 24 hours perspective and so. Now, the GNSS vulnerability mitigations can be due to different jamming, solar flash, and all these things, which we'll elaborate later on in terms of that. So this is about, you can say that the corresponding device, these kind of measurement devices also, and the timing devices also of the different different manufacturers, like this SEL 2488 satellite clock. This is time synchronized, you can say that platform, you can say that clock, that gives us, you can say that, both GPS and GLONASS, these Russian, you can say that, in the US, both signals it avails and gives the corresponding reliability index of the precision time to be very high in terms of that. So this, however, you can say that the corresponding okay. So I went to this and this. Yes, so this we finished. Now see the SEL, you can say that 2488, that the synchronized network clock that we are mentioning about, it avoids, you can say that, many, you can say, standards, and this it uses the interchange interrange, you can say, instruments group IRIGB provides the IRIGB format. It provides the time information in terms of that, and that you can say that leverage the corresponding Ethernet ports and so, and then you can say that the corresponding NTP or the simple network time provides SNTP and so. IRIGB time code repeats the each, you can say that, at every PPS pulse per second and so to the information, and that distributes the corresponding time information to the subsystem. So we have one antenna, one time receiver, and the time clock, network time clock, and that's, you can say that, provides the corresponding to the different measurement system in a subsystems by the IRIGB format and so. So this is about the IRIGB format side. IRIGB is about V, you can say that, like that, you can say that it has also code of other, you can say that A, B, C, D, and so and so, and that has the different things also, but widely in electric grid, B format, IRIGB format is being used in terms of that. So there are different available, you can say that, time synchronization perspective, which is available in the grid. These are, you can say that, in terms of GNSS, ELORAN, NISA, and other, you can say that, things are also available, and they have their own, you can say that, characteristic perspective and so. But as far the electric grid, the versatile utility is about this GPS platform, and the GPS, you can say that, and the IRIGB format into the system and so. So whenever we are talking about the time information, so from one point to the other point, we talk about that the corresponding communication system is required. Either you can say that cable, Wi-Fi, or you can say that fiber optic perspective and so. So where you talk about the communication time requirement in the electric grid, so it comes out to, we can say that this the goods platform today is, you can say, 650, you can say that, standard perspective and so. So this this table describes, you can say that, about this SCADA system, which follows IC 60870, that comes out with time requirement of 100 milliseconds. So timestamp, you can say, resolution of 1 millisecond. There is old, you can say that, data collection perspective, supervisory control and data acquisition systems, which is also ongoing. It's that available in the system, also most of the systems in the world. Now you can say that on the subsystem local area network communication, you can say that IC 6150, which is on the recent, you can say that, introduction perspective and so, that allows, you can say that, about 100 microsecond to 1 millisecond synchronization accuracy. So time synchronization accuracy requirement in terms of that kind of thing. And subsystem LAN, you can say that, following 67850, you can say that, goes to 1 microsecond, you can say that, perspective and so. These are of, you can say that, the timestamp resolution of, you can say that 59.6 nanosecond, around 60 nanosecond perspective and so on. So what I like to say that the new, you can say that the standards and so in subsystem, we talk about now digital subsystem that has the time, you can say that resolution accuracy level for the different devices to be having in the order of microsecond to nanosecond also in terms of that. So the time distribution in the power systems happens to be GPS, you can say that. It can be, you can say that network time protocol, or you can say that it can be a PTP, you can say that precision time protocol in terms of that, and it can be a SONET, carrier Ethernet, and so and so and so. Now, one perspective here, we say that the IEEE, you can say that standard on synchrophase standard or PMO standards talk about C37.1, these 2011. It talks about, you can say, total vector error of any, you can say, such measuring devices to be 1% and so. So this 1% of error, when it talks about that, if you account it to the all with the phase information, angle information, then the phase information is related to, you can say that angle, as you know, that the corresponding wave, you can say that this corresponding, this about the, you can put a time axis, or you can put, you can say that theta is equals to omega into t. So therefore, you can say that phase and time are related. So therefore, the corresponding time accuracy, which is being demanded from that, is in terms of the 1 microsecond order or so. So that's, you can say that about the new requirement in terms of that for the synchronized platform, synchrophaser technology, and so. So the time management characteristics, we talk about absolute time, we talk about the synchronized time, we talk about accuracy in a very precise precision perspective also, and the network time server and so. So, you know, what happens that in a subsystem also with Ethernet and all these things. So the corresponding merger unit, you can say that provides its own time stamping perspective. It acquires the sample data from the different devices and different points or through current transformer, potential transformer also, and then timestamps, you can say that, and provides in the corresponding communication platform so that all devices in the system can share in terms of that. The power system uses timing, so that we can say that about the we talk about time scale in second to milliseconds to microseconds to nanosecond and so. We talk about the clock accuracy of the atomic clock in terms of that, and then we have GPF's time stamping, you can say that of the microsecond and so, and then the phasor management unit, you can, when you talk about, you can say that reporting rate of, you can say that very 120, you can say that we are talking about reporting rate here, having 120 to 200, you can say that frames per second or measurements per second and so. SCADA measurement, you can say that the older version is having a sluggish one. So we can say that different time requirements, and particularly when you talk about high time, you can say requirements is in grid is about the real time events, something like grid oscillations or generator oscillations into the system and so. So coming to the, you can say that power system usage and timing, you can say that. So what happens that when you talk about that the relays, or you can say that, are protective devices in these systems, the relay decides of its own time in terms of that. So it calculates the time relative to a particular event, fault or so. Okay, so it don't require, you can say that, the precision time for the relay decision. But when you talk about the digital recorder, which the relay can also act to consider upon, which will be there used for the say that analysis and so. So that you can say that you talk about the precision, you can say that is required, and that you can say that about the precision of 1 millisecond, 2 millisecond for the recording devices and so. Now let us come to the some application perspective. We'll go to that. So the first one, you can say that comes in to my mind, you can say that is about the lightning correlation. So what happens that lightning many times creates faults in the system, but then the lightning, whether the fault is created by the lightning also, that is an important perspective, because if lightning has its lightning and followed by a fault happens to be there, then it results to a very likely a permanent fault or so. And that you can say that this means that insulator or something is being damaged at a certain point and so. So what is happening that in US, there are, you can say that lightning network now. So there are multiple, you can say, vendors which provide the lightning information. So the lightning information means the lightning arrestor, lightning information, and the corresponding, you can say that the corresponding time information, GPS, you can say that clock is also there. So any, you can say that lightning in that area happens to be there, is being recorded, we can say time information by the atomic clock also. So that resolution of time information of that is available. So if you have, I'm saying that login password available from them with payment, then you can get the data and correlate, you can say that your event, your fault in your particular system and so. So therefore, electric grid, you can say that uses that information to correlate the corresponding particular situations, fault or so trigger in the event and so. India also, you can say that has already started, not of course in I'm talking about electrical grid, but there in the southern, you can say that things you can find out some, you can say that some lighting observatory, you can say that having some 9, you can say that locations and so, and then you can say that is this kind of facility can be available, you can say. So this is a facility we talk about that, and which this is about the power system uses timing. So the lightning arrestor and the it uses the corresponding precision time or atomic clock, GPS clock, and that information is being harnessed into the grid to so that for the betterment of the reliability of the grid and so. So this about you can say that the power system uses of PM time and all these things. So this about we talk about phasor measurement unit, you can say that system, and that gives us a synchronized phasors. So when you say that those who are in the electrical science, so you know this phasor means computed for the sinusoidal quantity, which has you can say that magnitude and phase information, and which rotates anticlockwise with the speed of omega and so. So those you can say that having each phasor magnitude and angle will be a time stamp, and that we called about a synchrophasor. Synchrophasor means synchronized with time. Synchronize with time. So alternator synchronization or grid synchronization in one perspective, but here we are talking about synchronize with time. So each phasor is being a time take, and that gives us a synchrophasor perspective and so. So now these devices are available, you can say that, and we have so many, you can say that players are there to provide us 200 frames per second also. In 1 second we have 50 cycles, but 200 frames per second, you can say that also, that level of, you can say that reporting, you can say that available to there, so that you can have a better, you can say that visualization of the grid and so more details of this system and so. But it has its own issues also, that because such devices transmit the corresponding data to the center, we call phasor data concentrator, or you can say that center and so. So those centers are maybe distance high distance apart, and we require dedicated communication system like fiber optic and so. So any communication system has its own latency. So this arrival of the data and correlating that, aggregating that, and all these things takes time. So that latency becomes a bottleneck now today, you can say that, to implement many, you can say that, control protections or different objectives and so. Okay. So the application of PM, we can say that in the system now is a very wide application. If you Google, you'll find hundreds of real applications in the world, and there are probable applications of thousands in number and so. So this is a, when you talk about the smart grid initiative, this is the most promising, you can say that, technology in the smart grid, particularly in high voltage, and which is also coming to, you can say that, to the low voltage distribution system also in a big way in the grid automation or I'm saying that grid management perspective and so. I'm not going into details of, you can say that this such an information, because of the time synchronization perspective, makes the corresponding visibility of the system in one way. If you go to the POSOCO, you can say that New Delhi station, then you see that in one screen you can see the whole, you can say that 400 kV 765 grid, you can say that, and any event occurs, you can say that in the fault also, you can visualize, you can say that, you can notice, you can say that immediately reflected in that screen and so. So that is, you can say that big technology, you can say that, which has revolutionized, you can say that, in the electric grid operation and so. And that again, I'm telling about that is at precision time is the only answer to that. So we have also power quality monitors. Power quality issue, you can say that, in distribution and system and so. What happens that a consumer or somewhere a quality issue comes, someone is injecting, some load is injecting noise, harmonics, or distortion, sag, swell creating, or something like that. So then how to penalize that? So that you can say that who will be responsible for that? How to identify that? So we require essentially recordings, you can say that, at different places, and also that should be timestamp in terms of that, so that you can meaningfully, you can say that, identify that who is the corresponding culprit or issue making in the grid, because that creates problem to the other, you can say that, customers or users in terms of that. SCADA system, supervisory control database system, is a old system which reports typically from 2 to 6 seconds in terms of that. So that reporting rate, what is being done now, that with this time synchronization platform like with GPS based things, that when the SCADA sends the data to the next level, you can say that, to the management center, then the corresponding the data should be timestamped at that level, so that the data which reaches to the destination can be correlated effectively and efficiently. That's why I can say that in the SCADA also now this being corresponding precision time is being incorporated. That you can say that additional benefit of this kind of thing. Now come to this with a lot of renewable and you can say uncertainties, what is happening in this picture you can see also. So this is a small system, 2.5 megawatt, you can say that things, 2.5 megawatt, you can say that solar plant. And if you see this, you can say that these are all meter data. So in 3 days, one, day 2, and day 3. So these are three considered measurements in terms of that. So we can see this, what is the corresponding variation in terms of that. Same data, same measurements. When you go to the PMU data now, in the synchronized platform, precision time platform, then we see there's the corresponding day 1, day 2, and day 3 are like this. So this is the peculiarity. So it means that the corresponding what is happening in that time frame t-axis, more details are available with the PMU data, not with the metadata. So what happens that how frequently the corresponding change happens to be there. This is about the intermittency perspective, because the grid has to manage in terms of that. And if you think about the India grid, you can say that time Indian grid perspective, and so what we say that India has already harnessed. I already mentioned about that some 60 plus gigawatt of the solar plants, and so. But you see that one plant, you can say having 2.2, can say that I'm saying that 2.2 gigawatt. 2,245 gigawatt megawatt you can say plant. So at Rajasthan and so. So again you can say that 2050 you can say at Karnataka and so. So this you can say that says that how big the plants are in terms of the gigawatt order and so. When you scale up these corresponding systems, and if such a variability happens to be there, which is very unlikely of course, which if such a variability happens to be there, then it will have a great impact on the particular grid operation and so. It means that we require more details to the, you can say that system management side, system center side, system control center side, to have this, you can say that the operational details continuously with precise time and so. That's, you can say that, then only you can say that you can have a reliable system in the grid. The next application is on the fault location perspective. So whenever faults are inevitable, it is beyond our control, particularly overlay line and so. So now what happens that if fault happens to be there, a permanent fault, most of the faults are temporary, but if the permanent fault happens to be there, then the key people go and you can say that go for the maintenance and they do the corresponding needful things as early as possible. If the line is restoration becomes take times, then if this to this line a generator is connected, the generator is not able to dispatch power. So it is a revenue loss, you can say that to that generator, it is a revenue loss to the transmission agency and so. And also it is a challenging to the grid management perspective and so. So the sooner the corresponding line is being restored, the better it is. But how to restoration time can be reduced is nothing but that if you scan like in a distribution system, people's our you can say that people scan from all you can say that pole across if there is a because they don't have any you can say that mechanism to identify where the fault has occurred. Now that will you can say that take you can say that a lot of time you can say in terms of that. So fault locators are being used in terms of that. So what is happening in that? Now we talk about a traveling wave based fault locators. It gives you can say accuracy of you can say that it uses the traveling wave principle, which is having a very close to you can say that the propagation of this electricity. So velocity of very close to the velocity of you can say the light. So using that principle, if this you can say the recording device and this recording device are time synchronized, then what happens that in this case you can say that this the time here and time here can be compared, and then you can say that the difference will be you can say that what is the corresponding distance from this to this. This kind of platform which is available now with you can say that different things. So this is price you can say that some $70,000 and all these things, and the clock you can say that device this the network clock you can say that is around $1,450 and so. So these devices you can say that gives us a 300 meter you can say that accuracy level. So 300 meter you can say that is nothing but you can say that a between the distance between two consecutive you can say that tower, and that leads to you can say that you can reach the corresponding destination very quickly and repair the corresponding line and restore the line as early as possible and so. So this is you can say that again the precision time available at different device at different station level and all these things. But this technology has a problem unless I'm saying that India has also harnessed so many you can say that out of this also as per my knowledge in the power grid. Now what happens that this technology is a problem also because the cabling which will be connected in the substation side, that has also a travel time and so, and those must be taken into account, otherwise that leads to erroneous things in the calculation process and all these things. So technology available that has to be applied you can say a proper perspective and so. Now relays or protective devices typically you can say that phasor means one cycle takes around one cycle you can say that of a decision time. But when you come to the traveling wave perspective, it can take a decision in 1 millisecond, around 1 millisecond and so. That has also considered very time advantage and very accuracy also. But it has also own limitations and all these perspective and all these things. And these kind of protective devices also are available, you can say that from different manufacturers from that perspective and so. And that will give you can say that. So in a smart grid technology, these things becomes pertinent because these you can say that protection devices, such devices. Now we can say that the phasor-based approaches, you can say that are being found that they are vulnerable to renewable resources integrations, and like India is progresses a lot, and therefore we find that there are a lot of malfunctions in the available protection systems. So if you go to consider these kind of applications of traveling wave, which is independent of the sources, that gives you consider better scope of consider better performance or better reliability of the system. And so technology you consider is changing in a substation being merger unit, and so therefore what happens that a transformer, you can say that a transformer protection may be using different merger units. So these merger units you can say that uses different time information. So they have their own atomic clock information. So the atomic clock information must be considered very accurate, very precise. Otherwise, you can say that this will be creating problem in terms of that also. Now, these kind of, we can say that platform also helps in protection testing in the real time. We can record the recorded data of the fault, earlier fault can be replayed, you can say that on the same platform, same communication system, and this gives like a new domain of perspective with this kind of environment. And so a real world, you can say that applications on the control system perspective, we call, you can say that system integrated protection schemes to make, you can say that the system integration, you can say that maintain the integrity of the system. And so it is, you can say that in Mexico, two stations are there, 400 kV lines. So these you can say that take station 1 and stations 2 are there. So what happens that here you can say they have a hydro plants of around 900 megawatt. So if this line, you can say that double cycle line trips 400 kV. So there is a path on the 115 kV line which pushes, you can say, power to this. But this, you can say, the path is very lengthy and impedance of this is lengthy. So therefore what happens then, and again some of the transformers in this path are not designed for that, are very heavily loaded. So what happens that if this transformer trips anywhere, somewhere the line also trips, then the corresponding current, you can say that the power also cannot flow from this to this. So that becomes like, challenging to this side management and this side management. So therefore you can say that becomes and leads to an instability in the system. So what is being done that in case this, you can say, the line trips, the generation here is to be reduced. That's the task. So what they consider put that they put two PMUs, you can say, two locations, and they at one, consider control center here, that they provide the corresponding two PMU, you can say, data to real time, and the angle between the voltages of these two sides are real time available, and thereby you can say that the corresponding, if the corresponding angle increases beyond, you can say, that 10 degree or so, as per this data you can say reveals 10 degree, then the corresponding generation side has to be reduced, you can say that substantially, and then the corresponding system can be maintained. So that what happens that the network, you can say that even the corresponding double cycle line is not there, the system can be maintained of its integrity. And so this is a real world, you can say that phasor management technique, or the time, the precise time or precision time or GPS time information we use in a control application perspective. And so so there are multiple rate billings. India is massively connected, and there are so many interstate, you can say that ties, and so many states players are there. So each one for sales and purchases, and also, and that is you have every 15 minutes we have a time slot. And so these are, you can say that, or time of day, you can say that pricing business. And so therefore what happens that we have meters at different interconnections, and these meters, you can say that, decide that how much you need and what price, you can say that, will be dealt with the network operators. And so now the question is that these meters are having also time stamping, because what time who has purchased or who has sold, you can say that how much units. And so that becomes an essential thing. So the time information that they are become very critical, because this is in terms of the crores of rupees. And so that we can say that the billing process also requires that precision time. And so, and I already consider the power quality perspective, I have already mentioned in terms of that. So there are protection schemes also, which I have already mentioned before that one perspective. And so data recording also requires, you can say that, high precision times. And India has already integrated such, you can say that, phasor management units more than 2,000, you can say that. And these are having numerous application scopes, and they have started visualizing and all these things. These are massively going on in terms of that perspective. And so the sole purpose of this mechanism is that today's electric grid is more vulnerable, more challenging, with a lot of challenges, because the demand is increasing and then generation increasing, renewable energy perspective. And so therefore you can say that such a precision time based platform becomes more essential and require and all these things. So so I'm talking about even you can say that on application perspective in India grid. So there are a lot of oscillations happens to be there. These oscillations, you can say that in the grid increasing everywhere you can say that it is being noticed because of these kind of different events. And so this is about some 1,200 events in the WCC US perspective. 100 oscillations you can say that being observed, you can say that in India, you can say last year itself. And so what we have studied one perspective to this through the POSOCO Northeast, you can say that wing, the Shillong, you can say that team, that we found, you can say we developed a tool, you can say that the corresponding oscillation source, the oscillation source generally happens to be force oscillations happens to be there from this particular generator. And so these generators, you can say that source can be identified in real time, or you can say that in diagnostic manner. And so we applied, you can say that the PMO data, some 56 PMOs are in the Northeast region, and also so they provided us with the data, and we analyze, you can say that by the special technique using that one, and we find that you can say that yes, the corresponding source oscillations can be detected. So if you two can say several, you can say that real, you can say that database and also all these things, and we identify that what happened, you can say that in the particular event, and which generator or so you can say the cause of that, whether that disturbance is externally or if it is internal, you can say that how to consider identify this. So this technique clearly reverts to that. So these kind of techniques, what happens that if the corresponding generator is being identified, that should be isolated as quickly as possible so that the disturbance does not propagate and does not, you can say that, influence the security or grid reliability perspective. And so the second is that the people from the managing the corresponding generator, they don't know that who is the problem. So therefore, you can say that even the corresponding generator trips also it could not be identified. So by this kind of time synchronization platform, that we can identify that you can say that this grid has a problem. So therefore, that has to be considered look into to resolve the issue, because if you the corresponding issue cannot be resolved quickly, then the generator will be out for a longer period of time, and it becomes a revenue loss in terms of here in Northeast. We found that in one of the events, the one generating station lost, you can say that 3 crores of rupees also. So these about, you can say that how oscillation creates into picture, and this you can say that synchronized platform was available, and in you can say that last, you can say that Odisha Falin also the power grid, you can say that events. So line after line were tripping, and all the lines from this they are control room, they are able to see and all these things. This helps in, you can say that the managing the grid in that big events, like you can say that detrimental events like the hurricane and so, and it makes a sense. And then the restoration system also becomes quicker because you can mobilize the corresponding team, you can say that disaster management team, you can say that very quickly into the systems. There is another thing which India has progressed a lot recently also on automatic generation control. We call, you can say that the secondary frequency control and all these things, because I told you that unless we have, you can say that different control mechanism to maintain the system integrity, very, very challenging and all these things. So automatic generation control is that one which takes the corresponding tie line, you can say that error signal, and so here also you can say that the time information becomes very critical, and I believe you can say that becomes very meaningful. And India become targeting, you can say that a big, you can say that jump into this perspective, and so because our renewable resources are being integrated in a larger scale into this, and it is going to, you can say that on this scheme some 85 gigawatt, you can say that, and in the near future you can say in terms of that. One other applications to quickly summarize is that the Swedish railway application system. So they have, you can say that, integrated PMO in their railway supply systems, and found that has, you can say that, has a great revenue, you can say that in terms of that 1 million euro, you can say that per year loss, you can say spending they have saved in terms of that also. And this has become, you can say that, how to manage the corresponding that grid supply to the system, and that in terms of the voltage, in terms of these loading perspective, and so that the loss can be minimized and operations can be better management. This is a 15 kilovolt system only, and 16.67 consider hertz, compatible to that particular railway system and so. So precision time is, you can say that, very critical in terms of that. Different, you can say that precision times. Someone in a SCADA system, precision time may be in terms of second, but when you talk about a very critical control management side, the precision time should be microsecond and so and so. So that's, you can say that about the different precision time in terms of that and so. But then we'll come to something on quickly that these GPS signals are high or vulnerable. One, you can say that about the bad weather, like solar flakes and so may create problem. The other one, we can say that the intervention by intentional, you can say that, like spoofing, and you can say that, and so we see, you can say that jamming and spoofing, people intentionally put, you can say, some radio signals nearby to a station, and then that interferes that radio signal, because the signal which the corresponding the GPS receives is very low signal, and the radio signal. So if you nearby, you can say, create a radio signal like that, and then that will interfere to that signal, and the signal becomes weak. Or otherwise, intentionally, is what is being done is that similar radio signal being of higher strength being created, and that you can say that in a delayed version, so that you can say that the corresponding signal becomes distorted and leads to an erroneous decision process in the system. That becomes a challenging in terms of even in the cybersecurity perspective. And so, leap second, you can say that. Give me 2-3 more minutes time. Eh? One is, you can say, the issue with this GPS platform is the leap second issue. So the leap second, you can say that the leap year is one perspective that we know, but leap second is 1 second of adjustment, you can say that, required for, you can say that, to the atomic clock, and that you can say not a predefined. That is known 6 months advance only. That is different from the leap year adjustment. Now this leap second adjustment, IRIGB does not have that provision because it is not autonomous in terms of that. So that becomes a problem in terms of that. So some of you can say that I'm talking about India Grid also faced similar problem in 2015, and then they could notice that the adjustment of the leap second in some of the, you can say that, old PMOs were differently, and then the new PMO. So they could identify that they segregated the old and new PMO data and analyze and see that yes, that is the thing. And afterwards, when the corresponding leap second was being adjusted, that becomes easy. So this is that comes, you can say that, alert shutdown. So who is doing at what time? So this is about the standardization, and so you can say that testing perspective, and so in terms of that the conformity, and so cyber security issues, you can say, that comes, that I told, you can say that because of these kind of spoofing and so and jamming, and so it in terms of that. So this becomes a challenging. And if the cyber security happens with there, the control applications I was talking about that, then the delta angle will increase and unnecessary generators might trip and make the corresponding system challenging, and so this is a big challenge to the GPS based platform, or the platform we are talking about, the timing perspective, and so timing, it is not to the other system, other things is affecting the cyber security, is affecting the timing. Okay? So that timing information changes means, you can say that it the control action becomes very challenging in terms of that, and so I'm not going to details. We have the time is winning. I'm going to the some concluding remarks in terms of this. However, you can say that there are ways in terms of that, some timing remedies and options and all these things. One options I told you earlier also to that ACL product available is that not only GPS, the Russian, you can say that satellite also is being, both are available, then the corresponding GPS signal not availability, one signal not available means the other signal is available. That also you can say that creates problem. But how to overcome the jamming, and you can say that the spoofing aspect is a challenging task, that is a cyber security issue, and so. So some of the recommendation you can say that is about this, the accuracy, precision of the, you can say that the time, precision time aspect, whether we are using GPS or whatever it may be, and then the corresponding security perspective, and so are to be ensured on the perspective, and so. So some timing remedies and options are, you can say that there should be a GPS independent networks and all these things. So that you can say that can have these, and some IRIGB, you can say that issues in terms of that leap second perspective, and so that has to be in terms of that. So what to conclude out of this overall discussion, that precision time is important for grid management, grid the diagnostic purpose, or real-time management perspective, and all these things. So however, the GPS, you can say that signal which is being widely used for this precision time perspective in electric grid is vulnerable both from human cause and natural disasters. True. Disruption in GPS signals precision will jeopardize the corresponding thing. It means that we have to detect whether there is an intervention or no. Time synchronous enabled technologies such as synchrophasor based technology can be used for protection and control precision. Very good. Those are proposed and many things. My experience with, you can say, the last 15 years that I was enthusiastic that control and protections can be easily embedded in the system, and so that what happens that this is a critical function. You can say that the time information becomes a challenging thing for embedding this. So that you can say that PMO should not be used for automated controls and other missions. Critical, you can say that process. This is what the conclusion of the experts as of now. Using timing challenges have been resolved. Till the timing challenges have been resolved. I told, you can say that the signal becomes poor, and then some the solar flares and so may intervene, and so or the jamming and consider human intentional interventions jeopardize the corresponding things. Therefore, control and protection systems are to be not thought of in terms of that. You can say that till the corresponding fully effective, reliable, you can say that times information is available, and so. So cyber security is another challenge to this domain. So cyber security of the system, cyber security of the time, I'm saying the precise time information system also. I'm talking about time here. The power sector needs to protect future grid with better timing tools. I'm talking about precise time and practices, conformity and so, security and so, and improve the robustness of the resiliency of the system, resiliency of the own, and then resiliency and reliability of the power system also. So that you can say that is about that. How precision time is so important, you can say that in today's electric grid management. But then these puts challenges also. We are not able to apply, even though technology of protection and control things are there, because we don't have reliable, resilient precision time available today. So that is from my side. Thank you all. So there are a lot of literatures into these systems from different domains also. Thank you all. Any question, welcome.
Thank you, sir. Thank you so much. Wonderful presentation, sir. Now I'd like our audience to ask the doubts or they want any clarification on any particular topic of today's presentation. Namaste, Tripathi, sir.
Yes, namaste, namaste. Hello, Dr. Pradhan. Nice talk. I think you have given lecture equivalent of 4 lectures in one. Very, very compact, and you have covered a lot of subjects. Can I ask 1 or 2 questions?
Yes, sir. Please.
From the research point of view, as you are a IIT professor, I think you have pointed out certain things that the controller instability based on GPS, GIS data and all that is vulnerable. PMU data based on satellite information is also vulnerable. This vulnerability when you study in simulation and other things may be very clear to you, but
Sir, not audible. Sir, can you please repeat? Professor Tripathi, can you repeat, please?
certain things protecting the equipments. So except for,
Please.
as you say, resilience and reliability, do you think PMUs and other things are losing their sanctity the way we accepted them as the solution to this kind of problems? If we still are facing control instability, or still having false alarm due to PMU, data incompatibility, latent time and all that, how much practical engineers should take it seriously? I think IIT professor can take it seriously, but should we take it seriously in kind of a power engineer, application engineer?
Okay, sir. As far I understood, something was missing from your question. As far my understanding that PMO technology is mature technology now. PMO has grown like anything. But the problem, as I said here, is that the information, the communication system latency is one perspective on implementation. And as I told, on the timing perspective, precision time perspective, if the timing is not precise, then it affects the angle. And then the comparison between 2 PMO data cannot be achieved. So what is happening here is that one is that the clock at one point and the clock at another point, even if you can say that the atomic clock is pretty precise, but the local clock, which you can say that is disseminating the data to the different devices in the system, that becomes challenging. So therefore, what happens that the accuracy level which we are talking about, asking about 1 microsecond and so, because 1 millisecond corresponds to, you can say that 20 milliseconds corresponds to 360 degree, 1 millisecond corresponds to 18 degree, 1 macrosecond corresponds to 0.018 degree. So if we are talking about that 1 macrosecond also we are missing or inaccurate, then that can say that puts challenges to this one. So to achieve in a global, let us say talk about the all India, I can say that synchronized platform of 1 macrosecond becomes very challenging as of now. The other point you can say that what you say that when you talk about the application, yes, scanning and visualization and so is okay. But when you apply to the control actions, then it will be very detrimental. The second option, what I say that suppose the sound flares happens to be there, then the signal, because it is very weak, the signal will be not available to the GPS. Then if the GPS signal is not available to a particular the subsystem device, then what happens that the substation device run its own clock. How much that clock will deviate, who will ensure that? That has not matured, sir, about the local arrangement perspective and so. So that's why the NASPI consider document also, if you go through that, they clearly state this statement about that. No, control and consider protection is still to be considered, still to be considered certified, because the time precision considered is still to be matured in terms of that. The reliability and resiliency of the time information is not that considered matured. Sir. That is the bottleneck, I'll say.
Yes, of course. And the second question is that in USA, they have got a National Reliability Council. I think any fault or any analysis or any oscillations or any blackout anywhere is referred to that and a report is produced. POSOCO is trying to do that. I have seen some of the reports of previous breakdowns. But how do you feel that should we in India have a reliability council full-fledged like USA and refer them to build up a national level data so that everyone gets the benefit out of it? Or if you are aware, such a thing is already existing.
What? Hello, sir. I think we should have more stagnating thing. And what you say that I think you know better than me that at each regional level you can say that the different teams, different agencies sit and finalize that this stripping happens to be who is the consider that which agency is responsible for that. So every month or so they sit together and resolve that kind of thing. But like we are talking about North American, you can say that council. So that kind of thing should emerge. I think POSOCO is doing, as you told, many things in terms of that, but you should have a full-fledged team, you can say that, to address those things. Otherwise, unnoticed things will continue, and then our system will be in trouble future.
Okay, thank you, sir. Thank you.
Thank you.
Thank you, sir, for your questions. Now I would like to invite Professor Sanat Kumar, sir. Please.
Am I audible?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay. Professor Pradhan, I am not very sure whether this question covers your topic or not, but I was just thinking parallelly.
Okay, sir.
In Iran, they have a centrifuge system for enrichment of uranium. There, they have very high speed. You know, the motor has to run very high, so they have high frequency, 2,400 hertz or something like that. But I have read somewhere that the Americans were able to spoil the centrifuges by attacking their distribution system, that is electrical substation at their substation level. Similarly, you are talking about cyber crime, you know. Similarly, a power plant is generator is running. Is it possible to disable that generator from the power system side? Thank you.
Yes, sir. Actually, you are talking about cyber attack. This is going on. I think if you Google, you can say that you'll find cyber attacks frequently now. That you can say just like playing, you can say that virus or internet and so. So our can say that that's why in India government is also can say that Ministry of Power and all is not. You can say that only not you can say that power industry and so all industry. We need to consider cyber security perspective. Cyber security is not today. Cyber security has gone. You can say that in a few decades they have in other countries, advanced countries, they have started, but we have started recently only. So what you say that everything is possible, sir, because these you can say that generating station are also connected to you can say that different control system and so, and they are you can say that connected to the network and so. So anything is connected to the network means it is vulnerable. If you disconnect the corresponding from the network and if you only your own secure things, then it's something different. But however, you can say that because the grid cannot manage that way. So grid require information from this. Even you know that all are very now automated to the 400 kV substation, 765%, all are unmanned now. So therefore, we are controlling for a control center at one place and so many you can say substation we are controlling and so. So what we say is correct, sir, that all things are vulnerable in terms of that.
Thank you, sir.
Sir, Tripathi here again, I can't stop myself thinking. I think on one hand, we say that centralize everything and have the control in one place and try to work in microsecond protection level and all that. The other one, direction is that decentralize everything, disconnect from the grid, and have local management, local control, and be peaceful with your small network. So are we not contradicting? Various seminars are discussing this one, and we are telling one hand centralize everything, another side we said decentralization is solution.
No, sir, no.
I don't expect an answer, but your comment only.
Okay, sir. I think sir, both are required, sir. Like I know you can say that the Tata Power in Mumbai also that event in say that Kolkata we have CSC. So CSC in their 2012 blackout also CSC survived both the days. CSC did answer that for Kolkata did not happen anything. Even the eastern region was affected completely. So the point here that CSC disconnected whenever the grid disturbance find out, and then it manages of its own, we can say that generation and load balancing and so. So what we are saying is that yes, we are talking about the centralized things, true, that goes for the tertiary control, secondary control and so, but we have also, you can say that decentralized one also in terms of that to manage this kind of thing. Like we talk about the macro grid management also. Macro grid, you can say that when grid fails, it manages of its own. So then when to be disconnected, isolated, islanded, in terms of a city, in terms of a state and so, when the grid having a large scale of disturbances, frequency deviation and so, and then can you manage of its own way? That is about, you can say that's that decentralized one, localized one, you can say. This is what my way of thinking.
Yeah, I know that. Okay, that's the answer. Yes, thank you.
Thank you, sir. Now I would like Vijay Singh Yadav, sir, to unmute himself.
Okay, thank you. Good evening, sir. I am Ashok Singh Yadav, working as RF and microwave engineer at Stellite Technologies Limited, sir. Sir, my question is related to the use of antenna in the field of power system and the grid, as you mentioned. Sir, can you please clarify more? As I am from the background of microwave, so just I'm curious about that, sir.
So GPS antenna.
It is not that.
Are you talking about GPS antenna?
Yes, sir. Yes, sir.
So we have GPS antenna in our lab. We have for this PMU. So what we have to mount, you can say, so that visibility becomes better, and the cable length is a concern. The cable length should not be considered 120 meter and so. Like that I'm talking about. That depends on the manufacturer. And then we have what with that? This antenna is connected to this, consider through the cable to this your clock, and the clock you can say that then disseminates to the different devices. You can say that through the IRIGB or so different standard, you can say that messaging system and so. And these you can say that clock, okay, you can put one clock, and that clock disseminates the time information to the different devices in a substation.
Okay, sir. Sir, just to add on one more question I have. Sir, only GPS antenna is used for power system, or sir, we are using something at antenna like patch antenna also for the application perspective. Can we use it?
What is the antenna you are talking about?
Patch.
The patch antenna means rectangular patch.
So what is the objective of that? Target for that to receive which signal?
That to receive the signal means a bit higher frequency signal. Can we means?
I told you
in the field of.
So this also this corresponding satellite sends, you can say that the radio signal that having a particular frequency, particular frequency only. Like the Russian satellite sends a particular frequency and the US satellite sends a particular frequency. So that frequency measurement, I think correspond to that satellite should have the antenna should have been happened. I think you know better than in antenna perspective. Perhaps for all frequency band it may not hold good.
Yes, sir. Yes, sir. Okay. Thank you very much, sir. Thank you very much.
Thank you. Now I would like to ask Ajit Sapre to unmute himself.
I have a very general high-level question. At what level of renewable electricity on our grid would become more challenging to manage the disturbances and ability to make sure that the brownouts and the blackouts don't happen more frequently? Is it 30%, 40%, 80%, or none of above?
So, we have already reached 40% around. So,
no, that's capacity. No, the yes. Capacity factor of the solar is only 20%, right?
No. It is 160 gigawatt out of, you can say that 400.
No, but 160 is not available all the time, right? It's only 20% is available of that.
This is capacity. Agree? And we
No,
are
I
talking
know,
about
but
the-
what is actual electricity at any given time on the grid?
So let us say 20-25% what? The question raised, you consider that how much you can do. So the target is 100%. Agree? The target is 100%, and that is also achievable possible. So then what to do with that 100%? So then comes you consider intermittency and variability perspective. So we need storage. So can you provide that level of storage? That's the question. Are you talking about battery storage or hydro storage and so? Or can have you can say that running some other form, you can say that if you have a lot of hydro and that may not be having a problem. So that's the question, you can say that. But the target is that if you go to the recently I went to the July PS meeting also, that everybody now that grid farming and grid following things also, and it is in a mission, you can say that 100% renewable kind of thing. So what we are telling about now, what is happening that with more and more renewables, as per I am a protection man. So many you can say that protection systems are failing, malfunctioning. That is noticed. That is recorded by you can say that this Kosovo Power Grid also. Even if you go to the can say that we know you can say some statistical data that the southern grid you can say having a more frequent you can say that tripping, unnecessary tripping happens to be as compared to earlier years also. So that's what we say that grid management is not now easy. It's very difficult. It's going on challenging. So with more and more penetrations, it will be more challenging because you don't have an exact solution or technology available. I'm telling about protection perspective. The distance relay which is having all the grid protections here in India, AC system, the distance relay is having generic problem with the renewable resources. The question is that if you more having penetration more and more, then all the protection scheme will be vulnerable. Sometimes it will work properly, sometimes it will not work. Then that you can say happens to be there means that will be a big challenge to the grid. That is my way of thinking this.
Yeah, I mean today the cheap large scale gigawatt multi-days storage doesn't exist, right? We're talking about storage of few hours, not even a day. So once you go to higher and higher renewables, you have to think about storage and the grid. Today the solar and everybody is great because you have a grid and your penetration is in terms of actual delivered electricity is much lower. Not the capacity, but the actual capacity factor is only 20%, right? So actual penetration of electricity at any given time is not that large. Anyway, this is to me is not a solved problem, and I just wanted to confirm whether it is a solved problem or not. That's about it. But thank you. I learned a lot. I'm not an electrical engineer. I'm a stupid chemical engineer, and I listened to these talks to at least get some idea about what's going on in the world. So really, it was very informative, and I appreciate the discussion. Thank you.
Yeah, so what we say that is macro grid level, small scale level, it is being already there, operational. They are able to manage with these kind of things, storage plus. There are so many macro grids. You can just you Google Sweden Simiris village. Sweden Simiris village. You can see this in live data also they are providing. So the macro grid level is being already executed. You can see that now we are future. You can see that definitely after 30-40 years, 100% kind of thing. That is a mission. You can see that target globally.
Thank you.
And the key point here is that if you have a lot of hydro, then it hydro is 24 hours.
And I appreciate hydro is 24 hours, and hydro is the only 95% of the large scale gigawatt storage capacity is only hydro.
No, not storage. I'm talking, forget about storage is one part. The storage has 1 hour, 2
No,
hours.
also generation. Sorry, both generation and storage. Yeah, I mean nuclear is another renew. Nuclear is also green.
Yeah, but see that is 46 gigawatt, not small for us.
No, I appreciate that, but our 400 gigawatt requirement, if the economy grows at 7%, will also go up significantly, right? So you have to balance both. You cannot be static of where you are. So, no, thank you. I appreciate it.
Okay, thank you.
Thank you, Ajit sir, for wonderful questions. Now, anybody else from the esteemed audience, if they want to clarify something, or otherwise we'll come to the end of this webinar. No, sir, there is no raise.
Please propose a vote of thanks.
Okay, sir. Thanks. So it's I'm Dr. Renu Sharma, head of the Department Electrical Engineering and the host for this event. Professor Ashok Kumar Pradhan sir has very lucidly explained about timing, which is very essential to a wide variety of network functions and the equipment in the grids. Professor has explained precise and reliable time, which is at a very reasonable cost worldwide. He has also told managing and controlling these interactions requires like a mean to compare the status at one place and time with the condition all around at the same instant. Professor has also told that precise time and high-speed communication in the substations are enabling technologies to make this thing happen practically. And Professor has also told about highly accurate and free to access GPS timing signals, which has been incorporated into wide varieties of applications to improve system reliability, reduce operational cost, better understand power system operation, predict and prevent system-wide faults, also test and verify operations of protective devices. His talk has explained various ranges of applications related to time as important information, which has been throughout of his talk, discuss various sources and distribution of precise time, and also help us to understand how beautifully to apply commercially available products to synchronize power system equipment, even in the presence of large-scale renewable sources. Thank you, sir. We would like to hear you in future, and for the future collaboration, we look forward. Thank you, sir. On behalf of CSIR IMMT, INA, and Shiksha Anusandhan University, I extend my heartfelt thanks to you for presentation and all the esteemed guests present over here. Thank you so much.
Thank you. Thank you so much, sir. Thank you.
Thank you, Professor Pradhan, for excellent talk today.
Okay, sir. Thank you. Thank you, sir.
Can we talk for 1 or 2 minutes after this thing is over?
Sir, to me, you are telling?
Hello.
Are you talking to me, sir?
Yes, yes.